Welcome to Unreal Gems. In this video, we are going to take a look at how levels of detail work with skeletal meshes. Okay, so we are back in Maya. We are going to again create the LODs in an external program. You can see them right there. And what we are going to do is import those LODs in Unreal Engine. I'm not covering the process again because it's the same as with the static mesh. So let's just dive into Unreal Engine. Okay, so we have the FBX with the skeletal mesh and the LODs. And this time we are going to drag it and drop it. In the FBX import options, this time is going to be a little different. We can keep the defaults for the skeletal mesh, but we need to choose use T0 as a ref pose, so it doesn't give warnings because it has a baked pose. So in this case, we need to turn that on. You may not have to. And then we are going to select import mesh LODs. If we had morph targets, we would import them too, but this is not the case here. So let's go ahead and import all. And whenever it's done, we have our Lara imported, and you can see that if we double click on the skeletal mesh, we are going to be able to see the imported LODs. Do not worry about the materials because we are going to use another one without LODs, so I'm not going to bother to create the materials. You can see all of the LODs right there. LOD 0, LOD 1, which is the first LOD. Second, we lose detail and also vertices and triangles. And the last one, which is the LOD 3 with a lot less vertices and triangles, you can see that has a lot of problems, especially with holes, with the hands. You can see problems pretty much everywhere. So we are going to need to deal with this. But thankfully, Unreal Engine has a skeletal mesh simplifier, which we can use to auto-generate the LODs. So you can see the LODs. I have made all of them visible, and you can see the sections, the LOD info, which has settings related to the LOD generation. You can see the reduction settings, which also have more settings related to LOD generation, and the build settings that have to do with the mesh settings, which are not as important to us. So as you can see, we can re-import LODs, not the LOD 0 due to it being the base mesh, but in the LOD 1, 2, and 3, we are going to be able to re-import. So in this case, in the third one, it has really low quality, so we could fix the problems outside, like for example in Maya, and then re-import it. We can also use the mesh LOD coloration just to check if everything is working properly. LOD 0, original mesh. LOD 1, first level of detail. LOD 2, second level of detail. LOD 3, third level of detail. You can see that everything is switching properly. Colors are changing, so we are golden. Okay, so that was a small review of the process of importing external levels of detail in Unreal Engine. Right now, we are going to take a look at how we can generate them automatically as with the static meshes, but this time with the Skeletal Mesh Reduction tool. So that is going to be better for control, like for example in the case of the hands or other problematic areas that we had with the Maya generated LODs. So with Unreal Engine, we are going to be able to customize the reduction options to keep level of detail where we want it and not have those holes or those weird hands. Okay, so we are back in the project. We are going to just check, just in case, the plugins that we have enabled, because if you don't have the Skeletal Mesh Reduction plugin, the Skeletal Mesh Simplifier, you are not going to be able to auto-generate the levels of detail in Unreal Engine. Skeletal merging is also pretty cool, but it has nothing to do with the topic at hand. So let's go ahead and just check that you have the Skeletal Mesh Simplifier. Once you have that, you need to also check in the project settings, because there are several settings related to the Skeletal Mesh Reduction plugin. Well, it's just one, but if you don't have it enabled in the editor Skeletal Mesh Simplification, you need to enable the Skeletal Mesh Reduction plugin. So you need to set it to Skeletal Mesh Reduction. Once you do that, you are good to go, and you should be able to auto-generate the levels of detail for the skeletal meshes. You can see that in the editor section, you have the options. It's just the same as searching, but so that you know where are they located. Okay, so we are back in the level. We need to choose a skeletal mesh without levels of detail. In this case, it's Lara, but this time it has not been externally imported with levels of detail. So you can see that in the LOD picker or in the LOD viewer. So if you click, you are going to see that it has no LODs, and there you just see LOD 0, which is the base mesh. So if I activate custom, obviously it's not gonna have any because there are no LODs, as I mentioned before. So we now have to specify the LOD settings, because there is where we are going to specify, for example, the number of LODs and which one is going to be the base LOD. If I had external LODs that I wanted to import separately, you can also do it in the LOD import menu. For the number of LODs here, I'm going to choose 4, because it's quite balanced. So between geometry reduction and the rest of the things, you can also choose LODSettings Asset, so you can store your settings for creating LODs and use them quickly the next time. You could also set other things like the minimum LOD for a platform or for this platform, but for now we are just going to set the number of LODs and apply changes. And with that, we will have our LODs created. Later, we will see how to create the LOD asset so that you can save time. But for now, let's just keep it clear and press apply changes. And after a while, Unreal is going to calculate those 4 LODs. And when it is done, you will see them with the LOD picker, and you will see near the created LODs the generated tag. So you can see if they are imported or not. If they have the generated tag, they are not imported, and so on and so forth. So everything is okay. It has created the 3 LODs. So LOD 0, remember, is the base mesh. So it has done what we have asked for. If we take a look at the sections, we can see the materials. We can see the LOD info with, for example, the screen size when the LOD switches, if you remember correctly, and other interesting settings that we are going to take a look later. Again, we could change anything here, for example, to aid with the problems that we will have in the lower LODs, and hitting then the regenerate LOD, we would regenerate the LODs and see the changes right there. If we hit the regenerate LOD button, we could also remove the LOD and re-import the LOD. If we now switch, this is the base mesh. This is the LOD1. You can see that it retains a lot of the detail. LOD2, you can see that it is still pretty good. We can start to see problems in the face and in the necklace. And LOD3, which has a lot of problems in the face, in the necklace, and in the hands, for example, in the belt, etc. So our objective here is being able to fix these problems, but without losing quality. So we can see the LODs, LOD3, LOD2, LOD1, LOD0. So everything looks okay visually, from a LOD switching point. So right now it's all going to be about fixing those more aggressive LODs using the LOD info settings, the reduction settings, and regenerating the LODs, also the LOD settings, of course. And after regenerating the LODs, we should be able to get rid of those problems and get the proper LODs. Okay, so let's deal first with the face. Let's go to the LOD3 and let's go to reduction settings. And inside reduction settings, we have the Lock Mesh Edges option, which allows us to preserve the mesh surface as much as possible at the cost of having some more vertices. So, for example, this is going to probably help with the head, which right now is not preserving the surface, the contour of the face. So let's regenerate the LOD and see what happens. You can see that it has improved, but it is not perfect. Since we here have a very aggressive LOD, very low amount of triangles and vertices, we are still going to have problems in the face, but you can see that it has improved. If instead of the LOD3, we go to the LOD2 and do the same thing, activate Lock Mesh Edges and then regenerate the LOD, you're going to see that the face has improved quite a lot. Just take a look at the eyes and the side of the face and you can see that it has way better results. So you can clearly see what Lock Mesh Edges is doing. Let's now get rid of it because we want the bad result again. So we are going to regenerate without the Lock Mesh Edges option because we want to take a look at how the bones to prioritize option can help us with the detail in certain parts of the skeletal mesh. So in this case, it is not going to be the same as with the Lock Mesh Edges because you are not losing detail. So in this case, remember that Lock Mesh Edges preserves more vertices. The bones to prioritize do not affect the reduction. They just prioritize what parts of the skeletal mesh need the geometry. So I can choose bones and the parts of the skeletal mesh that are related to those bones are going to preserve more detail. So in this case, I'm choosing the head and also I'm going to choose several other bones that are going to help with the task at hand. And we will see if we, while keeping the low amount of vertices, can get some of the precision back in the head. So I'm choosing the head, the neck, and also the other neck bones. So neck 02. And we are going to take a look at the regeneration now to see the effect. You can see that it has kept a lot more detail in the head, so the head has improved. But as we have very low vertices and triangles, we are going to have problems logically. Let's try Lock Mesh Edges with the bone prioritization and we should see a little improvement. You can see here that it's not the best, but this is the best result that we have up until now while keeping the amount of triangles and vertices really low. So again, we could also prioritize sections, so to keep certain materials or to give certain materials importance. It's just the sections to prioritize option, and we could also add more bones, like for example in the hands, so that we can prioritize the hands. In this case, you can see that the fingers are getting distorted. I'm not gonna do the full hand because it has a lot of bones and it would take forever, but let's prioritize the middle finger in the right hand so you can see the difference. So I'm choosing just all of the all of the bones related to the hand. I'm just gonna do it quickly. I'm gonna fast forward this process because it's quite painful. So I'm just looking for the bones and choosing the proper bones. And once it is done, if I regenerate the LOD, you are going to see that the middle finger should improve and we should get some more precision in the hands. You can see that it has improved. It's not quite as big and as deformed as before. So you can see that everything is working fine. We are doing great. So right now we are using a weight of prioritization of 1 right now, but you can choose to give more importance to the bones using that option. So again, you are going to be able to see it, and you are going to see that as we turn up the weight of prioritization, things are going to probably improve. Again, remember the sections. We could choose a section. In this case, I could choose section 0. In this case, you can see the sections right there. In this case, it's the hair, probably related to the head. So let's leave it there, or we can get rid of it. No problem. But just know that that will prioritize certain sections that may have more importance than others. Very similar to the bone prioritization, but in this case with the materials. As I have mentioned before, we need to, when prioritizing, take a look at the weight of prioritization option. I'm going to prioritize with more importance. Instead of 1, let's go ahead and go for 100. And you're going to see that the hands and the head are going to get more importance. But take a look at, for example, the feet and the legs. They have been worse. If I turn up the prioritization, you are going to see that the legs are going to be even worse, and some other things get even worse. So we need to be careful, because maybe right now the neck is also not the place to have all of the prioritization. So choosing this carefully is important. And you just need to choose the bones that you want to prioritize, that are important to certain things. If you choose more bones, they are not gonna be good for the prioritization. So in this case, you can see that the final result is way better. We have more precision in the hands, more precision in the head. And right now we have still small holes, but remember that we are using just 2000 triangles, 2000 vertices. So I think this is pretty good, a pretty good result for viewing at a distance. So let's now take a look at the reduction settings, which are going to help us to be able to tune the LODs at our desire. Okay, so if we were calculating the LODs for the first time, we would go to the LOD settings and then to the LOD 0. And there we would establish what the reduction settings will be. So in this case, let's close it up a little bit because I have a lot of things on a screen. We would go to the reduction settings of the LOD 0. We could choose the triangles. If we want to have the triangles as termination criteria, vertices, first percent satisfied, max triangles, max vertices, and first max satisfied. Okay, so triangles and vertices are percentages, so the percentage that we want to keep. The max triangles will be a number of max triangles or max vertices, and we will now take a look at some examples in which we can see how those percentages affect the number of triangles and vertices that end up in the simplified mesh. So let's take a look. For example, in the first LOD, you can see in the reduction settings that it's trying to keep 25% of the original triangles. Next, the 12%, and next 6%. As you can see, this is quite aggressive and maybe it's not the best option. We could change any of those and regenerate the LOD and we would see everything change. If we do it in the LOD 0, we could click apply changes and it would generate the rest of the LODs, and then we would be able to switch the percent of triangles or the max triangles count or whatever we want in the reduction settings of each LOD. And as I mentioned before, then we can regenerate it and see what's what. There are other options, like for example the lock mesh edges that we saw before, and lock vertex color bounds, which also tries to preserve vertex colors if your mesh has them. And again, morph targets and so on and so forth. I will leave the table again so that you can check the different parameters, and if you are in doubt, you can see the definitions of every single one of them. So as you can see, it is quite straightforward and you can gain a lot of control with every single setting here. We will still take a look at some of the settings and we will go over some of the most important ones. If we go to the last LOD and we switch from the 6% that we want to keep to 0.1, which is the 10%, you're going to see that things are going to probably improve a lot. Yeah, certainly. And we only have 1,000 triangles more and 1,000 vertices more. So you can see that switching the percent of triangles, especially in the highest amount of simplification, is going to be really important. You can choose also vertices in percent, max triangles, and max vertices, and first percent satisfied, and both satisfied in the max, first max satisfied, which are going to be pretty much that if one or the other is met, the algorithm is going to stop and stop reducing the mesh detail. So with that, this is a review of the main settings. There are other settings, but they are related to fine-tuning more than core concepts. So just take a look at the chart that I showed before. And last but not least, I want to take a look at the termination criterion and how to choose it. So if you are rendering limited, you are going to choose triangles and try to bring down the number of triangles. And if you are memory limited, you are going to choose vertices and you are going to try to bring down the number of vertices, either with a max amount if you know the budget or with the percentage. But that's pretty much it for the termination criterion and how to choose it. Just in this case, I will keep triangles on. Okay, so talking about other important settings, like for example, volumetric correction, that deals with the fact that we may have problems with the volumetric boundaries of the mesh when we are simplifying it. So in this case, if we leave it at 1, it's going to try to keep it as close as possible to the original mesh, but we can offset the volumetric correction. We can choose 0 and try to bring it in. So reduce it. So the mesh, the simplified mesh, occupies less volume than the original mesh. You can see how the face got shrinked compared to the version before. And if we choose 2, you can see that it's a little bit more volume than in the original mesh. So the ideal thing is probably keeping it at 1 and not touching it, so the default value, but so that you know, for example, for collision or whatever, if you need for an LOD to be a little bit bigger or a little bit smaller in terms of volume, you can do it with this setting. So it's quite useful. Okay, so let's now take a look at another common procedure that we may have to do. Just in this case, we are going to take a look at how to remove bones in lower levels of detail. So For example, in this case, we have the bones to remove option, which is an array. If we add an element, you're going to see that another bone pops up that we need to choose. In this case, we will choose the twist, lower arm twist, something like that, not important. Like for example, it is related to higher quality animation. So in this case, when we regenerate the LOD, we are going to see that that bone is going to be removed in this LOD. If we go to the skeleton tree and take a look at the bones, if we go down to the lower arm twist, you're going to see that it appears grayed out, and the thing that says that I have gotten rid of it in a level of detail is that circle that appears right next to the name. So that small circle, gray circle, that is going to mean that we have gotten rid of, removed the bone in a lower level of detail. Why would we want to do this? Well, it's pretty simple. If you have less detail, some bones related to higher quality animation may not be necessary and you may want to remove them for performance reasons. So in this case, that's pretty much what this option is used for. Okay, so let's go back to the LODs. Let's go back to the automatic switching of LODs. Let's go to the mesh detail coloration and let's take a look at how they are switching. As with static meshes, here we also have available in each LOD, in the LOD info section, the screen size. So we can choose a screen size depending on a platform or not, and we can choose when the LOD is going to pop up. Exactly the same as with the static meshes. So in this case, I choose that when it represents 70% or so of the screen, it will pop up. Take a look at the current screen size. This is another method. If you remember, I did a procedure in the other video in which I used the windowed viewer and I adjusted the screen size depending on how the mesh behaved on the level. So if you take a look at the current screen size, you can see that using 0.7 is going to pop up right away because we based it on the current screen size, which was more or less that. So you can see how we calculated it and you can see how it's switching whenever we want to, as soon as the current screen size is 0.7. So everything is looking good because this first level has still a lot of detail and it is switching properly between levels. So there is another parameter which is new compared to static meshes, which is called LOD hysteresis. This parameter is to avoid flickering between the different levels of detail. So if I was close to a point in which they will switch and I keep on going back and forth, back and forth, back and forth with the camera like this, it may produce some flickering. So using this parameter, like for example here that I used 0.1, is going to introduce a little lag when it is switching from a complex level of detail to a simpler one. So in this case, it's if you see flickering, just take a look at this parameter and try to fiddle with it and see if it gets rid of the LOD flickering. So in this case, I'm going to leave it at 0 because there is no such problem. So I'm just not gonna touch it. And with that, we can take a look at some other parameters that can also be useful. For example, in this case, we can see the LOD settings that we didn't look at before. Like for example, the minimum LOD. If you remember, in the static mesh, we used platform overrides. In this case, I'm going to override this parameter for desktop and also for mobile. So in this case, the objective here is using a base LOD, so a minimum LOD, that is not as high detail as the default one. So in this case, I'm going to leave desktop at 0 because it's powerful enough, but in a mobile platform, the first level of detail may be problematic. So in this case, I'm switching to the level of detail number 2. So I'm starting up with only 5K triangles and 3K vertices when I'm playing on mobile. So whenever you see that plus sign, it's either an array or a platform override. So just look for those plus signs if you want to switch settings depending on the target platform. Sometimes, as I mentioned before, it will be an array of just, for example, in the bones to prioritize, it's an array, but more or less always it's going to be a platform override. So in this case, if you remember, we talked before about LOD settings and that we could generate an asset that could save us time when generating LODs. So let's take a look at that. Let's open up the asset, double clicking on it. And as you can see, you have the settings that you have created and the LOD groups. So you have the LOD settings, like for example, the minimum LOD, then you have the LOD groups with everything inside them. So in this case, you have reduction settings, LOD info, and more or less all of the settings that you could toggle, like for example, screen size, LOD hysteresis, and so on and so forth. So you can prepare this in advance and then just select the saved asset and not have to go one by one updating all the options for other skeletal meshes. Just be aware that if the bones change or some things change, you may have to create another asset, because if the bone names are not the same, the mesh reduction is going to fail because it won't find the bones. Okay, so let's get back to the engine because it has been a while since we have seen a render, and let's take a look at how the levels of detail on our skeletal mesh are working out in our level. So if we get far away, you can see that they are switching properly. First of all, the LOD number 1 is popping up. You can see that then the LOD number 2 is popping up, and when really far away, LOD number 3, which is the less detailed one, is also popping up. If we go back to lead and we take a look at the quality, you can see that right now even the third LOD, which was, remember, less detailed and with a lot of problems, from far away you cannot tell. And by the way, you can not also tell when we are switching LODs. So that's more or less our objective, and we have more or less being able to achieve said objective, because as you can see, there is no visible quality loss. We can switch, go back, go forth, and we cannot see a damn difference. So this is pretty cool because we are getting performance for free. We don't have to do anything else apart from calculating those LODs, and when we are far away, our mesh is not going to be as costly. Well, so that has been it for this video. As you can see, levels of detail in skeletal meshes are quite useful. You can see that they are quite easy to use and you gain performance while not losing visual quality. So there is no reason not to use them. If you have liked the video, remember, like and subscribe. You will be doing me a huge favor.